Now back to our own subject matter. Where do the mathematical methods enter the picture? How can mathematics help us to improve philosophical argumentation in this case? Once the mathematical philosopher has stated a philosophical argument clearly enough in order to judge it, and if she has already determined the argument to be logically valid, she subjects its premises to mathematical scrutiny. In the case of Zeno's argument, premise 6 is the one that she should be suspicious of. P6. If for all n it takes Achilles the amount t0 plus and so on plus up to tn of time to get from x0 to xn plus 1, where each of t0 and so on up to tn is a positive amount of time, then the amount of time t0 plus t1 plus t2 plus and so on, in which Achilles is to pass each of x0, x1, x2 and so on, is not bounded by any finite amount of time. In the original texts on the paradox, this premise is not stated explicitly. In fact, hardly any of the premises above are stated explicitly. Rather, all of them need to be extracted from the very brief story that we are told. But it is difficult to see how Zeno's argument is meant to go through without anything like premise 6 above. Let us put this premise to the test now. Say, t0 is half a minute. So it takes Achilles half a minute to move from x0 to x1. Furthermore, assume t1 to be a quarter of a minute. It takes Achilles a quarter of a minute to move from x1 to x2 and so on. Generally, let tn be 1 over 2 to the n plus 1 of a minute. If one thinks about it a little bit, this entails that we are assuming Achilles to be twice as fast as the tortoise. A conservative assumption, that is, since presumably Achilles is much faster than just twice as fast as the tortoise, but never mind. More importantly, you might think, hey, none of these additional assumptions were part of Zeno's story. Why are we allowed to invent them? And aren't we all of a sudden changing the subject matter? Because instead of talking about space and time, we're talking about numbers now. But that's not the right way of thinking about it. First of all, although we did use the familiar plus sign when we formulated premise 6, all we meant with this initially was that amounts of time are put together somehow. There was no need as yet to interpret the plus as a sum of numbers. What Zeno does need is a way of getting from the tortoise being ahead of Achilles at each point xn to the conclusion that the tortoise will be ahead of Achilles forever. And it is hard to see how Zeno could get that without putting together periods of time, and in fact infinitely many of them, to the effect that these added up periods would become arbitrarily large. But that means Zeno had to presuppose premise 6 or something like it to be plausible. Now about the numbers. Presently, we are putting premise 6 to the test. Our method of doing so is by building a little mathematical model of the situation that Zeno is describing, and in which we can then determine whether premise 6 is true in it. For that purpose, we are now measuring amounts of time by means of numbers. Or, since only the numbers will be relevant in our model, we might just as well identify amounts of time with the numbers. Accordingly, the putting together of non-overlapping periods of time gets identified with summing up their corresponding numbers. Why are we allowed to do so? Because we are describing a possible way in which the race might have proceeded. Achilles might have been precisely twice as fast as the tortoise. And we're describing it in the same manner that we would find plausible also in real-life races, by measuring times by numbers. If we had good reasons for not believing it to be plausible to measure time like that, our toy model would not be a good one. But that does not seem to be so. Now back to premise 6. What our formal toy model tells us is that we do not have good reasons to believe it to be true. One might have thought that adding up infinitely many positive numbers must lead to arbitrarily large sums of such numbers. But that is not necessarily so. For consider the amount of time t0 plus t1 and so on plus tn that it takes Achilles to get from x0 to xn plus 1 in our little mathematical model. t0 plus tn plus and so on up to tn is nothing but 1/2 plus 1/4 plus and so on plus 1 over 2 to the n plus 1. Now it is easy to prove mathematically that 1/2 plus 1/4 plus and so on plus 1 over 2 to the n plus 1 is less than 1. However large the n, whether 1 or 2 or 3 or any other positive integer. So the corresponding sum does not become arbitrarily large, but is always bounded by 1. In other words, whatever the n, Achilles reaches xn in less than 1 minute. We do not state the proof here, but geometrically one can see that if we view these numbers as areas of regions in a square with side length 1, then they add up to less than an area of 1, whatever the n. By a standard theorem in the calculus of real numbers, this implies that the whole infinite series, t0 plus t1 plus t2 plus and so on, that is 1/2 plus 1/4 plus 1 over 8 plus and so on, converges to a real number. In our case, that number can be shown to be exactly 1. This means that in our little mathematical toy model, it takes Achilles precisely 1 minute to catch the tortoise. And this is so in spite of the fact that he needs to traverse infinitely many segments of space. The reason is that from one segment to the next, the distances that he needs to cross become much smaller, and the time that Achilles needs to pass them becomes much shorter. So much shorter that overall these periods of time add up to a finite number, 1 minute. All of this can be made perfectly exact. The only instrument that one needs to do so is the calculus, or what is also called real number analysis, one of the classic fields of modern mathematics in which concepts such as infinite sum, convergence, and limit are made precise, and in which various theorems that involve these concepts are proven rigorously. This shows us that as things stand, premise 6 of Zeno's argument is not plausible after all. As things stand, Zeno's argument does not force us to question our commonsensical assumptions on movement. Instead, we ought to reject one of the premises that he seems to have taken for granted. That is, that putting together infinitely many positive amounts of time must lead to arbitrarily large amounts of time. Because that's just not true. Without that premise, Zeno's argument does not go through anymore. The argument from premises 1 to 5 and 7 to 9 to the conclusion is not logically valid anymore. Now, this does not mean that Zeno could not have come back to us with a different argument, by which perhaps he would have rationally convinced us of the illusion of movement after all. This is not excluded by anything that we said. For instance, he might have replaced premise 6 above by a couple of new premises so that the resulting argument would be logically valid again, and where the new premises would be more stably plausible. The new premises might, for example, show that one cannot actually measure amounts of time in terms of numbers, or that one cannot add up amounts of time in the same way as we are adding up numbers. All of which would prohibit us from invoking our toy model from before, or the like. But as things stand, we have no indication of any of this. We have done our best to state Zeno's argument in clear and precise terms, and we found that the resulting argument should not convince us of the non-existence of movement. That's all. None of this is a criticism of Zeno either. His paradox is wonderfully creative and stimulating, and he did not know about the later mathematical progress on the treatment of infinite sums. But we are still perfectly allowed to criticize Zeno's argument. In fact, being the great philosopher that he was, that's exactly what he would have wanted us to do. It is modern mathematics which prevents us from taking one of the premises of Zeno's argument to be justified. And in this way, mathematics helps us to avoid drawing the wrong philosophical conclusions. That is one reason why it can be very useful to apply mathematics when we do philosophy.